So then the last part is I basically renamed the program to be mypid.py. We go ahead and import the my-debugger, that's the debugger code we just saw a moment ago. We go ahead and create an instance of it. We're going to have a raw input that's from the keyboard and basically prompt the user to give us a PID for the process we want to attach to. We go ahead and call that function that we saw defined of attach. We're going to run our program, run our debugger, and then it'll finally detach. So I'm going to minimize this code here. You need to bring up a DOS window and go to the location of where your Python code is. Now, I actually did set Python, I set a Python home as a system variable, and I set that in my path so I can run Python commands from anywhere. So, but what I'm going to do here is I'm actually going to run Python mypid.py. Okay, so now it's prompting me. Remember, if you remember that raw input, we're prompting the user for a PID. So we're going to use something easy. We're just going to use calculator because everybody has it. So I'm bringing up the program calculator. Now, in order to see the PID, I bring up the task manager. And by default, the PID column is not shown, so you're going to have to actually go to that. You're going to have to actually select that. It's a select columns, and you can select PID there. So the number of my PID for calculator is 2064. So I'm going to attach to 2064. And what you see displayed is the result of that class that we saw, the debug event, and it shows our event code, our thread ID, and of course, remember those event codes that we saw 1 through 6, and now we're looking at them there. If you remember, the 5 was an exit, so if I actually close the calculator, then I get my 5, and of course my process has been terminated and it's no longer available in the task manager. So now we're going to move into looking more closely at the immunity debugger. So the immunity debugger is a free debugger that is written purely out of Python, the language Python, and it comes with a graphical user interface that I think is quite useful. Now, this particular debugger is designed specifically for vulnerability research by Immunity.inc, and it is known to be one of the best debuggers for reverse engineering. I did include their URL for you to download the debugger. So first, before we actually open up an executable inside of the debugger, you need to understand all these panes. There are a lot of different windows to the debugger. We're only going to be looking at 4 of them in this particular talk just because we're keeping it to a beginner's point of view. But if you start at the top left-hand corner, you're going to be looking at the disassembled code. And we sort of saw this when we looked at the GDB debugger. We took the bin bash program, we set a breakpoint, and then we disassembled that code. Well, this is looking at the same view. What's nice about Immunity is it actually color codes the text, so there's a little bit better readability, but the information is going to be the same. So if you look at the arrows that I've added, on the far left hand side you're going to have your address location. So that's for example, I'm pointing to 00401526. So that's some location in memory for this particular instruction. The next column I'm pointing out is that opt code, and we talked about the opt code together on a previous slide. Basically, this is the low-level instruction to the CPU. Then the next column shows us our assembly code, and we talked about that, how the opcode and assembly code go together, but that's just one higher level representation of the same instruction. And then you see in that command, that assembly code command, references to the different registers that we've been talking about. So the particular one my arrow is pointing to is EBP. Now, if you take your eyes to look at the bottom left-hand pane, that is showing you a hex dump of the binary code. Now, you can change the hex to ASCII if you want, etc. And there's a version of ASCII that's shown there. You can change the way that you look at this, but basically this is your memory. So this is the stuff in your heap, etc. Now, if you take the bottom right-hand pane, that is your stack. And so this is going to be interesting as you look at the execution of your programs to see where, what's at the top of your stack, where the EIP is going to do its next instruction, etc. And then finally on the top right-hand side, you can see the place where we have all of the registers and basically what the next instruction is that they're pointing to, so whatever location. And the one that I want to point out is EIP. In this particular example, we have EIP pointing to 00401500, and we can see that EIP looks like it's happy, it's running fine, it's not corrupted, so everything is good. So that's a little bit of an introduction. Realize there are a lot more panes, there's a lot more to Immunity. It can do some really great stuff, but for our beginning purposes, we're just going to focus on these 4 panes. Now, shellcode writing. The first thing that we should address is what is shellcode. Now, shellcode essentially is machine code, okay? It's your ops code that does not require any further compiling, linking, or assembling in order to be run by the CPU, and that's kind of why it's so sneaky. Now, shellcode is usually created to spawn either a local shell or bind to a particular port on a victim machine so that you can spawn a shell on a remote machine if you're attacking a machine. And basically it's used, in a nutshell, it's used to elevate your privileges, right? So you want to inject shellcode or malware as it's generically termed, but basically you want to inject this shellcode to be able to perform something that you really aren't authorized to perform. That's kind of the ultimate goal. So the other thing that I want to point out on the slide is I'm referencing 3 areas where you can get shellcode from these URLs. These are great resources. Exploit-DB is probably the most famous. There's all sorts of shellcode as well as authors that have contributed. They have the programs on that website that you can download and you can take a look. A lot of the authors have even gone through the trouble of getting rid of any sort of null terminators or bad characters so that the shellcode performs properly. So there's been a lot of good analysis and contribution done to these particular websites. One thing I do want to give a nod to is Metasploit commands. You can create shellcode using various Metasploit commands. This talk is not going to cover Metasploit, so I just wanted to let you know that we would cover that in a different talk. Now, the demo that we're going to go through is basically twofold. Now, the tools and what I'm using for this demo include Windows XP 32-bit on the VirtualBox, Notepad++, Python 2.7. I am going to start with a script that was written by the author of Gray Hat Python book. I'm going to start with his script, but I'm actually going to run, after we run his version, we're going to run my version. So I actually modified it in part 2 to have a breakpoint and basically to be able to look at the code a little bit easier inside of Immunity so we can see what is actually happening at runtime and how our shellcode is getting executed. So we will be looking at, we will be using Immunity Debugger to attach to a running process in order to do that. So now we're going to look at our shellcode writing example. And for this demo, we're going to start with this code injector.py file. Basically, this is the actual script from the Gray Hat Python book. And so we're going to run his script just the way that he has it. I am going to add a small twist, and that we'll actually test out the shellcode in a C program. I'll show you how to do that. And then in the second half of this, we're going to run the same script, but we're actually going to add, I added a breakpoint, and I added some other things to the shellcode so that it's a little bit easier so we can see it inside of the Immunity Debugger. So we'll look at that after the fact. So for right now, let's go ahead and take a look at the source code. I'm going to use the Notepad++ editor. And what we can see is for this particular process, it's expecting 2 parameters. Okay, so you can see that there. It's expecting, basically, technically it's 3, right? Because it always starts at 0, but 0 is the name of the program. So the first actual param is going to be the PID, and that's going to be the process that we're going to attach to, just like we did before in the other demo. And then the next parameter would be the PID to kill, which of course is the same PID. So that's why we're going to put it in twice on the command line. Now, if we were to take this shellcode and say we wanted to test it out and make sure it didn't have any errors or any problems, we could actually copy and paste it into a C program, which I've done here. And essentially all the C program does is it gives me the length of the shellcode and lets me know what the return value will be. Now, in this particular example, we actually are expecting 2 parameters, right? Which is the PID ID twice. So it's going to give me an error when I execute it, but at least I will know that what it's anticipating is what I'll be feeding the program. So let me just show you. I'm going to compile it. Compiles without any errors, and then when I run it, it says here, invalid syntax, please specify valid numeric value for PID. So that's good, that's a good sign. We can see that our shellcode length is 3, so this isn't a very big shellcode at all, which is nice because as you get more into understanding shellcode, you realize that you've got to create kind of a buffer so that you don't create an overflow or mess up or corrupt your EIP by flowing over your buffer amount. So that's all intermediate stuff, and we can get into that in the next time. So we've tested our shellcode, and that looks good. So basically, as we get our parameters in here, there's going to be this padding that's done to our PID to kill. You can see we've got some padding there. Then we're going to use some A's for A's. And down at the bottom here is this line right here, this is where we actually go ahead and execute our shellcode. So we're not going to go into every line of this, but just a general understanding that we are injecting shellcode into a running process. So I'm going to close the source code for now.